Atomizing air and liquid fuel are injected into each combustor through a liquid fuel nozzle. The atomized fuel is ignited by a spark plug. Once the reaction is started, the combustion process is self-sustaining as long as fuel and air are available. When normal trip oil pressure is established, VH4-1 allows hydraulic oil to flow to the actuator of the liquid fuel stop valve. The stop valve opens and liquid fuel flows to the fuel pump. Once 33FL-2 signals that the liquid fuel stop valve is open, the control system energizes the solenoid of the liquid fuel pump clutch. The clutch is engaged and the fuel pump is driven by the accessory drive gear. Fuel flows to the bypass valve and the flow divider. The flow divider sends an equal amount of liquid fuel to each combustor. Magnetic speed pickups in the flow divider sense the rate of fuel flow and provide the control system with signals proportional to the amount of fuel being sent to the turbine. The control system compares the called-for fuel flow to the actual rate of flow sensed by the magnetic speed pickups. When the demand for fuel increases, the control system begins to close the bypass valve. As the bypass valve closes, more fuel is forced to the flow divider. From ignition to full load, the control system modulates the bypass valve in response to feedback from the magnetic speed pickups and the fuel demand. Each fuel oil cartridge can be removed and replaced without taking off the combustor end cover. The fuel oil cartridge is inserted through the center of the DLN2 fuel nozzle. There is only one mode of operation when using liquid fuel in a DLN2 combustor. From ignition to full load, fuel flows through the fuel oil cartridges and burns as a diffusion flame. Liquid fuel operation requires steam or water injection to reduce NOx emissions. In addition, without steam or water injection, the turbine cannot be operated above a certain load capacity. Without steam or water injection, the combustor exhaust gas temperatures will exceed the design limits of the first stage nozzles. When the control system gives the signal to fire the unit, atomizing air is delivered to the combustors and one of the liquid fuel pumps is activated. The liquid fuel stop valve opens and the bypass valve begins to close. This forces fuel to the flow divider. The flow divider distributes the liquid fuel to the turbine combustors. Feedback from the magnetic speed pickups is used to modulate the bypass valve based on the fuel demand and the control parameters. One fuel pump will sustain full speed, no load operation. During the gas turbine loading sequence, a second fuel pump is activated. 2 fuel pumps are required for base load operation. The third pump serves as a standby pump. When operating on liquid fuel at base load, the system must use water or steam injection to reduce NOx emissions. During liquid fuel operation, fuel oil is fed through the fuel oil cartridge and is injected into the combustion chamber. Atomizing air is fed through the fuel nozzle and impinges on the stream of fuel oil, breaking it up into a mist of fine particles to optimize combustion. This diagram illustrates the end cover of a DLN2 combustor configured for dual fuel operation. There are connections for liquid fuel, primary gas fuel, atomizing air, tertiary gas, water injection, and secondary gas fuel. When operating a turbine equipped with a dual fuel system, the turbine is able to start on either fuel and switch to the alternate fuel after full speed has been attained. In this example, the turbine is operating on liquid fuel. During operation on liquid fuel, the stop-speed ratio valve is closed and the gas-fuel passages in the primary and secondary fuel nozzles are being purged with compressor discharge air. When the control system gets a signal to transfer to gas fuel, the primary and secondary gas fuel purge valves are closed. The stop-speed ratio valve opens and, after the gas fuel lines are pre-filled, gas fuel flows to the combustors. As the flow of gas fuel is increased, the amount of liquid fuel flow is decreased in order to maintain stable operating parameters during the transfer. Once the transfer to gas fuel operation is complete, the liquid fuel pump is turned off and the liquid fuel stop valve is closed. The liquid fuel nozzle purge valve is opened and atomizing air purges the liquid fuel nozzles. Liquid fuel purge continues throughout gas fuel operation to prevent fouling of the liquid fuel nozzles.